let's get it going, folks. So let's see. I'm going to get the red color here. Okay, so we're starting here with 9.2. Oh, I wanted that to be red. Okay, great. So Vesper Theory, VSEPR, Valence-Shell Electron-Pair Repulsion Theory. So this is basically a model that builds upon Lewis structure, okay, and looks at the arrangement of valence electron pairs around a central atom and attempts to predict what the shape of this molecule should be, the three-dimensional shape, okay? So there's a couple things we need to discuss with that. We need to talk about the electron pair geometry. So this is the arrangement of bonding pairs as well as lone pairs about a central atom, all right? And so with that electron pair geometry, we have to first start, number one, by, man, this is going to get annoying until I find a new app. So we first start by drawing the Lewis structure, okay? And hopefully you should be all good there. And once we draw the Lewis structure, we then have to determine what's called the steric number of the central atom, okay? And so that steric number is the number of atoms bonded to the central atom plus the number of lone pairs on the central atom. I really like to think of the steric number as basically the number of things around the central atom. So I'm going to add that as a text box here. Okay, let's see. Yes, the number of things around the central atom. And as you can see, this is going to be only slightly awkward with my inability to use my stylist. Okay, steric number, number of things around the central atom, where a lone pair counts as one thing. Okay, so let's go and do some examples. So what is the steric number for the 5 structures shown? So let's first start with this carbon dioxide. Okay, so there I've got my carbon central atom. Okay, and it might be tempting to say there's 1, 2, 3, 4 things around it, but remember that is the number of atoms bonded to each central atom. So really this carbon just has a steric number of 2. Okay, so steric number of 2 because it's just got 2 oxygens around it. Okay, so let's look at this next one, boron trifluoride. Okay, and as you might guess, there's the boron is the central atom. There's 3 things surrounding it. So that is a steric number of 3. And if we keep going through this list, you can see carbon tetrachloride is going to have a steric number of 4. Phosphorus pentafluoride, 1, 2, 3, 4, 5, is going to have a steric number of 5. Okay, and then this sulfur hexafluoride is going to have a steric number of 6. All right, so these ones were all pretty straightforward because there was no lone pairs around the central atom. So, but remember, if we did have a lone pair on the central atom, that counts as one of these things, right? It's the number of things bonded. Let's see, it's the number of things bonded, right? Plus the number of lone pairs. Okay, great.